Hey everyone, it's Emma AY from CybrBrief, and today we're diving into the world of network design with a focus on two key concepts: segmentation and software-defined networking, or SDN. These aren't just buzzwords, they're essential for keeping your network safe from cyber threats. So let's get into it. First up, segmentation. Think of your network like a city. You wouldn't want every street to connect to every other street, right? That would be chaos. Segmentation is all about creating these separate neighborhoods or zones within your network. It's like putting up barriers or gates, making sure not every device can communicate directly with every other device. This separation is crucial because not all parts of your network are created equal. Some desktops, servers, or users are more important than others. For example, you wouldn't want just any user to access the CEO's files or the financial server. That's where the principle of least privilege comes in, which we'll talk about more in a bit. Now let's consider how we segment. Traditionally, we use VLANs, which are like virtual walls in your network, but there are other ways too, like using IPsec for secure communication or internal firewalls to control traffic. And then there's air gapping, where you physically isolate some parts of your network from others, like keeping your most sensitive data on a computer that's not even connected to the internet. But let's dive deeper into this principle of least privilege. It's not just about who can see what on your computer. It applies to everything in your network. An application shouldn't have more access than it needs, just like you wouldn't give your house keys to the mailman. Servers should only run software necessary for their job, nothing more. This reduces the risk because if one part gets compromised, the damage is contained. Imagine if every user could access every database or server in your network. That would be like giving a tourist the keys to the city, including the mayor's office. By limiting access to only what's necessary, you reduce the attack surface. If an attacker compromises a user's account, they're not going to have free reign over your entire network. This principle is about giving just enough access for someone or something to do their job. No more, no less. Moving on to software-defined networking, or SDN. Imagine if you could control your entire network like you control apps on your phone. With SDN, you can. It's like having a bird's-eye view of your whole network, regardless of where the hardware is physically located. SDN treats network hardware more like a canvas where you can paint your security strategy programmatically. This means you can set up segmentation without worrying about the physical layout of your network. It's especially powerful in cloud environments where your network might span from your office to a data center across the globe. Here's where it gets really cool. With SDN, you can respond to changes in the network dynamically. If you're using a hybrid cloud with both private and public components, SDN sees it all as one, making segmentation consistent no matter where your data is. This is a game changer because traditional segmentation methods like VLANs can struggle to keep up with such dynamic environments. To give you a clearer picture, traditional networks are like building with bricks. Each brick is a piece of hardware, and once you've laid them out, moving them is tough. SDN is more like using software to draw your network layout, where you can redraw lines or add new rooms without touching the physical structure. Now, why does all this matter? Let's talk about NotPetya, one of the most devastating cyber attacks in history. This malware spread like wildfire, causing billions in damage, largely because many networks lacked proper segmentation. If there had been even basic segmentation, NotPetya's spread could have been contained, significantly reducing the damage. NotPetya was a wake-up call. It showed us that without segmentation, an attacker can move freely within your network, from one computer to another, escalating their access until they've achieved their goal. But with segmentation, you throw up roadblocks, making their job much harder. For example, in the attack, a company that had no segmentation saw NotPetya spread across their entire infrastructure. Had they segmented their network, the malware might have been limited to one part, giving them time to respond or isolate the issue before it became catastrophic. Let me dive deeper into NotPetya. This wasn't just any malware, it was a worm that exploited vulnerabilities in software, particularly targeting Ukrainian organizations but spreading globally. It masked itself as ransomware but was actually more destructive, wiping out data rather than just encrypting it. The attack began with an accounting software update that was tampered with, allowing NotPetya to gain initial access. From there, because of the lack of network segmentation, it moved laterally across networks, infecting everything in its path. This event underscores why segmentation is vital. It's not about if you'll get attacked, but when and how you can limit the damage. In the case of NotPetya, companies with segmented networks could isolate the infection to one area, perhaps one department or server, preventing the worm from spreading further. To really hammer home the importance of segmentation, let's look at how you can implement it. Beyond VLANs, you can use network enclaves, which are essentially mini networks within your network. They're particularly useful for sensitive data, like in financial institutions where you might have an enclave just for trading systems, separate from other IT services. Another approach is the use of micro-segmentation, where you go even finer, segmenting at the application or workload level. This means even if an attacker gets into one part of your network, they can't easily jump to another part. It's like having tiny, secure rooms instead of one big open space. And let's not forget about the human element. Training staff on the importance of segmentation and the principle of least privilege is key. If your employees understand why these practices are in place, they're more likely to follow security protocols, like not sharing passwords or accessing systems they don't need to. Now, diving back into SDN, it's revolutionizing how we think about network security. With SDN, you can automate security policies, dynamically adjust them based on threats or changes in your network, and do all this from a centralized control plane. This means if you detect unusual traffic, you can reroute or block it without manual intervention, often in real time. SDN also allows for network virtualization, where you can create virtual networks on top of physical infrastructure. This is like having multiple virtual roads on one physical road, each leading to different places without interference. This virtualization makes it easier to manage complex networks, providing security in a more flexible way. Think about how you could use SDN for a disaster recovery scenario. If one of your data centers goes down, SDN can automatically redirect traffic to another location, keeping your services up and running. This level of resilience is crucial in our always-on world. But there's more to SDN than just segmentation and automation. It simplifies network management. Instead of configuring each switch or router individually, you manage everything from one place. This means updates, security policies, and even troubleshooting can be done more efficiently, with less room for human error. Now, let's talk about some practical applications of SDN. For instance, in educational institutions where you might have thousands of devices connecting daily, SDN can manage access control, ensuring students can't access faculty resources, or manage bandwidth so that one class doesn't bog down the entire network during a live stream. In a corporate environment, SDN can help in implementing zero-trust security models, where trust is never assumed, and verification is required from everyone trying to access resources. With SDN, you can dynamically enforce these policies based on user identity, device health, or location, tightening security without the usual administrative overhead. However, with all this power comes responsibility. SDN controllers, the brains behind the operation, become prime targets for attackers. If they can compromise this, they could potentially control your entire network. That's why securing the SDN controller itself is paramount, using strong encryption, authentication, and ensuring it's isolated with its own security measures. And speaking of security, let's not forget about the potential for SDN to introduce new vulnerabilities. Because SDN relies so heavily on software, any bug in that software could have widespread consequences. Regularly updating and patching your SDN systems is as crucial as locking your front door. But here's where SDN shines in security. It gives you the ability to rapidly deploy security measures. If a new vulnerability is discovered, you can implement fixes across your entire network in minutes rather than days. This can be the difference between a contained incident and a network-wide breach. Let's consider how SDN can be a tool for advanced threat detection and response. With the visibility SDN provides, you can monitor network behavior in real time, looking for anomalies that might indicate an attack, like unusual data flows or access patterns. This kind of monitoring can be automated with machine learning algorithms, making your network smarter at spotting threats. Now, let's switch gears back to segmentation because it's not just about stopping lateral movement of malware like NotPetya. It's also about protecting your network from insider threats. Imagine an employee with too much access decides to take data or sabotage operations. Segmentation can limit their reach, reducing the potential for damage. For instance, if an employee only has access to the department they work in, they can't cause havoc across the whole company network. This is especially important in environments where employees might leave the company or change roles, as it ensures their access rights are appropriately managed. Another practical example of segmentation in action is in healthcare, where patient data security is paramount. By segmenting networks, you ensure that sensitive medical records are only accessible by authorized personnel, reducing the risk of data breaches which could affect patient privacy and lead to legal repercussions. In healthcare, segmentation might mean that only doctors and nurses in a specific ward can access patient records for that ward, preventing unauthorized access from other parts of the hospital network. We also need to talk about how segmentation can protect against supply chain attacks, where attackers use trusted suppliers as a vector. If you segment your network, even if an attacker gets in through a third-party service, their ability to move beyond that entry point is severely limited. For example, if you have a supplier providing software updates, you can segment their access so they can only reach the systems they need to update, not the rest of your network. Let's delve into the real-world application of these concepts. For businesses expanding into the cloud, SDN and segmentation become even more critical. As you move services to cloud providers, maintaining consistent security across both on-premises and cloud environments is a challenge. SDN can unify these environments, making sure your security policies are applied everywhere, regardless of where your data resides. This is particularly useful in scenarios where data might move between your local servers and cloud storage. In terms of compliance, segmentation is often a requirement. Regulations like GDPR or HIPAA demand strict control over data access and movement. By segmenting your network, you're not just securing data, you're also ensuring you meet legal requirements, avoiding hefty fines. For example, under GDPR, you might need to isolate personal data of EU citizens in a way that it's only accessible to staff who need it for compliance or service provision. And let's not overlook the scalability aspect. As your organization grows, your network complexity does too. SDN allows you to scale your security measures alongside your network growth. You can add new segments, adjust policies, or increase bandwidth without a complete network redesign. This means as you onboard new departments or expand into new markets, your security infrastructure can grow with you, maintaining the same level of protection. Now let's discuss some of the challenges. Implementing SDN and segmentation isn't without its hurdles. There's the learning curve for your IT staff, who need to understand these new technologies and paradigms. Training is essential, not just for the technical team, but for anyone who interacts with the network, to ensure they understand the implications of these security measures. The need for new tools is another challenge. SDN requires different management software than traditional networking, which might mean purchasing new systems or integrating with existing ones, which can be costly and time-consuming. Also, ensuring these tools are compatible with your current infrastructure is vital. There's also a significant cultural shift in how your network is managed. Moving to an SDN environment means changing from a hardware-centric approach to a software-driven one. This can be difficult for organizations used to traditional network management, where each device was individually configured. We must also consider the cost. While SDN can save you in the long run through efficiencies and better security, the initial investment in new technology, training, and possibly re-architecting your network can be substantial. However, ignoring these advancements might cost you more in terms of breaches and downtime. It's about balancing upfront costs versus long-term benefits. Let's touch on the future. As we move towards more IoT devices and 5G networks, the need for dynamic, programmable networks like SDN will only increase. The sheer volume of devices connecting will require networks that can self-heal, self-optimize, and self-secure, which is where SDN's programmability comes into play. Imagine a scenario where your network can automatically adjust to accommodate thousands of new IoT devices during a product launch, all without manual intervention. But remember, no technology is a silver bullet. SDN and segmentation are tools in your cybersecurity toolkit. They should be part of a broader strategy that includes regular security audits, penetration testing, and an incident response plan. And speaking of incident response, imagine how SDN can aid you here. If there's a security incident, you can rapidly isolate parts of your network to contain the threat, and then reconfigure your network to bypass compromised areas, all while your team investigates. This could mean isolating a segment where a breach was detected, preventing further spread, and then rerouting traffic to ensure business continuity. Lastly, let's talk about the human aspect again. All these techie solutions need human oversight. Continuous education and awareness programs are crucial. Your staff needs to understand these concepts to appreciate why they're important and how they contribute to security. It's not just about the tech. It's about fostering a culture of security awareness where everyone is vigilant and proactive about cybersecurity. Understanding and applying these network design approaches isn't just about preventing the next NotPetya. It's about making your network resilient, adaptable, and secure. And that's what we're all about here at CybrBrief, making you a master of cybersecurity. If this has gotten you thinking about how to protect your network, stick around. I've got loads more content coming that'll keep you on your toes. Whether you're a pro or just starting, we're in this together, making you an expert in cybersecurity one episode at a time. Don't forget to like, subscribe, and ring that bell for more cyber adventures. Until next time, keep learning, keep questioning, and stay secure, my friends.